Quick introduction. I'm Christopher Leonard. I'm leading the ViroAlert campaign, looking after the product development and commercial aspects of the ViroAlert product range for temperature screening. Our presenter today is Dr. Fiona Turner. Fiona heads up our physics department. So unlike many of our competitors, we really do have a fundamental understanding of the physics and the challenges of human body temperature measurement. And hence we have a physics department which is unusual but of great value in this area of expertise. A little bit of background on Land's heritage. We've been in non-contact temperature measurement. We're known globally, over 70 years worth of innovation. We're based in the UK, just outside Sheffield, in Bromfield, where we have design, manufacturing, and world-leading calibration facilities. As we step through this webinar, we're going to touch on accuracy, reliability, and repeatability of measurement, which is a key feature of adequate and successful temperature screening systems, and we'll go into a little bit more depth. Beyond our standard product range, which typically serves heavy industrial users, steel, glass markets, oil and gas markets, we've also been involved in human body temperature measurement since the original SARS epidemic back in 2002. During that outbreak, we led the way in terms of innovation, delivering what is known as in-scene calibration, which we successfully patented. We'll cover this technology a little more as we step through the webinar. This is now the gold standard in terms of human body temperature measurement, and is referenced in guidelines such as the Food and Drug Administration in the US. In terms of track record, there's over 1,000 of these systems installed globally, and we have been involved following SARS through the MERS, the Middle East respiratory syndrome, swine flu, and avian bird flu prior to the outbreak of COVID. So back to the matter at hand. COVID-19 is a major challenge. Recent news of potential reinfection. It doesn't look like this is going to go away anytime soon. So the greater resilience mitigation methodologies that a business or an institution can implement, the greater resilience they will have to the virus and the transmission of the disease. Typically, social distancing, hand hygiene, face coverings offer mitigation methods, but none of these are infallible. Adding additional temperature screening, provided it's implemented with appropriate knowledge and adequate equipment, can certainly add to these measures and increase the resilience of a business or an organisation. So just moving on to some of the benefits and limitations of the other mitigation methods. Face coverings and masks, they can reduce the risk of transmission if worn correctly. However, they can often be uncomfortable. They tend to be a one-size-fits-all. It can be impractical in certain situations. It's not always possible for all people with health conditions to wear face masks in all situations. And indeed, unless the mask is treated with real clinical rigor, it could actually increase the risk of contagion as you increase the concentration of the virus potentially on the outside of the mask. If you don't then treat that with due care, you could be increasing your own personal risk of infection. Hand hygiene, again, another core measure and very effective. However, people tend to inadvertently touch their face, sometimes up to 20 times an hour. So hand washing, if you're infected, or you need to rub your nose, your eyes, or other sources of infection, could quickly transfer to your hands and then subsequently to everything that you touch. COVID is very resilient. The World Health Organization is currently advising that it can remain infectious for periods of 2 hours to 9 days. So maintaining a sanitized environment can be very onerous, very hard work, and in high traffic areas, very difficult to sustain. Social distancing, again, another great methodology for mitigating risk. Delving into the research, some published articles in The Lancet indicate that reducing distance dramatically reduces infection rates. However, maintaining those extended distances is difficult and impractical in many situations. And indeed, many of your guests that are coming to your facilities, hotels and resorts, maintaining those social distances at all times can be a real challenge. So at this point, I would like to introduce our presenter, Dr. Fiona Turner, who will talk us through some of the benefits and limitations of temperature screening systems.
Hello.
Hi, Fiona.
Hello. Hello, everybody.
So, Fiona, I was wondering if you could share some of your expertise and knowledge around handheld temperature screening. This is a methodology that is attractive. It's typically cheap to buy a handheld thermometer, and therefore people believe that they are up and running with temperature screening. I was wondering if you could just give us some comments around handhelds, their accuracy, ease of use, etc. for the audience, please.
Okay, well, this isn't something that Land recommends for the temperature screening application, but there's two basic sorts. There's a sort of in-ear thermometer that people can get for home use, and that they're used in medical applications as well. Very accurate, but the real problem is how close you have to get to somebody to do that measurement. You can't maintain social distancing with it. So despite their accuracy, it isn't the business that we're aiming to fulfill the need for. It's not really a screening system. You can use it to check an individual's temperature from quite close proximity, or else the person has to handle it themselves, and then it would have to be cleaned every time. Then there's the next step. There are devices that they're a spot pyrometer. They measure an infrared temperature from a small spot, and people normally direct it at the face somewhere, and those can be used from a metre away, but those are a lot less accurate, those systems. One component of the less accurate is that where the measurement area is, there's a variation of a couple of degrees, maybe 5 degrees in temperature across your face. So even if you always aim for the same place, if you get a different operator the next day, they might aim for a different place. This is something that we do see in the spot pyrometers we sell to the metals and glass industry, where on one particular night shift, people think that the whole glass melt tank runs hotter because a certain operator tends to look at a different area. So that can be one problem. Somebody has to choose where to measure on the face, and it might not be always the hottest place. And also, I think they're used to be from a metre away, which isn't quite social distancing again. And you've got to have a person stationed in your foyer doing that. You may be paying their salary, maybe they're there anyway, but you're still taking their time, and you're putting them at risk of catching it themselves, and then also spreading it to the next people who arrive.
So essentially you're looking to implement a risk mitigation method, and you're violating the social distancing guidelines to do that?
Well, yes, that's why Land haven't gone down that route in offering our product.
So, I mean, just touching on what you said there, you've got the potential inherent inaccuracy in the device itself, and then variance with operators if they're not quite getting the same reading.
Yes, for the handheld measurements that are used from a distance, not from the ear thermometers, but then you can't keep yourself socially distanced if you're using one of those.
Okay.
Those are accurate. Don't mean to.
So in terms of utilising handhelds for temperature screening, you've got the issue with violating social distancing and potentially putting the person doing the measurement at greater risk. And then subsequently, should they become infected, everybody else entering the facility at higher risk of transmission. And then I think added to that, whilst the initial purchase price is quite cheap, you mentioned there about the operator carrying out the measurement, so the cost of ownership is perhaps not as cheap as it first appears, because you're paying the wages for somebody to carry out that task as well.
Absolutely, I just wouldn't say it was the best option.
Okay. The other question that we've been asked at the other end of the scale, Fiona, is the use of high resolution imaging is for multi-person or crowd screening. So I think one of the requirements out in the market is people are looking for a solution where there's not going to be a queue waiting for people to get in. So this seems quite attractive. I was wondering if you could share some of your knowledge around multi-person or crowd scanning with us.
This is the opposite end of the spectrum, and Land Instruments make these high-resolution thermal images for other applications, but again, we've chosen not to use these for the temperature screening for fever in people. The problem is the accuracy of a thermal imager system depends on how far the person is from the camera. Even the very expensive, very good instruments, there is that dependency with a thermal imager. You can't make it completely independent of distance. So with a crowd scanning system, maybe our competitors have algorithms to deal with that, with how far away people are, but then the device has to be mounted in a very particular position, and they're normally mounted up above the crowd, and then you've got an extra variation of how much hair people have hiding their face from above, or some people have less hair than others, don't they? So you're seeing a much bigger face area.
Okay.
So even though there are algorithms to correct for that kind of thing, you're making a problem for yourself. And we didn't think that we could achieve the same level of accuracy as with our thermal imager with the reference source within it. So I don't really see how other people are doing that.
Okay, so I think to sum that up, it's a much higher cost of ownership, initial purchase price on some of these units I've seen from sort of $15,000 up to maybe $30,000, but you're then potentially in the same situation where reliance on that accuracy and reliability and repeatability of those measurements is potentially in question. Indeed, I think the FDA, the Food and Drug Administration in the US, has issued guidance. I've also seen a number of experts in this field question the accuracy of multi-person screening and the viability of temperature screening for COVID-19. Okay, thank you very much, Fiona. I think that covers two areas where we've had prior questions, and hopefully that's educated our audience a little bit. So we've perhaps shared with them what's best not to do. I think now moving on, what would we recommend in terms of temperature screening?
Well, the direction we've gone in our offering to this market is to use a lower resolution thermal imager. Now, these are much, much cheaper than the prices that Chris was just saying, because basically you pay per pixel to some extent. And so with a lower resolution thermal imager, we've got enough resolution here. We do a face detection, not a recognition. So you'd be able to tell it was a face, not my face, in the thermal image. But that's enough. That's enough to know it's a face, and then choose the hottest areas of that face automatically. And we advise a limited range of working distances, so that the person being measured would be around 1 metre to 1.5 metres away from the camera while that measurement was taken. Face detected automatically, and the measurement performed. Also within the imager view, there's a reference source, which is a black body source. I can explain the word black body further if you'd like.
I think, sorry, if you could just, I think, explain to the audience part of the challenges of measuring human body temperature, how that can be affected by ambient conditions, and what the black body does to overcome that.
Right. Well, the real problem with the human body temperature measurement is just how accurate it's got to be. Within 1 degree centigrade or Fahrenheit is the difference between somebody being healthy but having warm skin and being feverish. So we've got to do a more precise measurement than for any of our industrial measurements on the steel, the glass, the aluminium. We need this extreme accuracy, and we need that despite the background being maybe 35 degrees C or the background being 10 degrees C. We've got to be able to measure in all those different conditions. And the best way we found to do that, this is our patented reference source system, is to put something in the image, just a small square that's a very tightly controlled temperature, and then compare the human face to the reference as it's being measured. And the reference source is a black body source. Now, a black body is a bit of a physics holy grail, really. The word, I think, was coined by Max Planck, who was doing his research into thermal emissions and infrared back in about 1903. His theory of black body radiation was coined. The theory is that every object, every warm object, emits infrared radiation. The wavelength and the intensity depends on how hot that object is. So we are all emitting all the time at fairly long wavelengths, around 20 microns wavelength. Hotter objects, things that you can see glowing red, will be about 600 degrees C, or higher up, things that appear white hot at 1000 degrees C. But coming back to the black body, that's the perfect radiator, a true black body, and it emits every scrap of radiation that Max Planck thinks it ought to, according to its temperature. We are not perfect black bodies. We have an emissivity factor, which is less than 1, so we don't emit the true theoretical amount. But if you can have a black body reference source with an emissivity very close to 1, and so it's behaving as you expect, and one that you can tightly control electronically the temperature of, then you've got this perfect reference source, and it's much easier for the camera to see whether a person is within 1 degree of, in fact, within less than half a degree. We've got plus or minus half a degree accuracy, and we can only do that because we're measuring relative to that black body target.
Okay, thank you. Could we ask you now, Fiona, to give us a quick demonstration of the unit in action? Just bear with me, because whilst we're professionals in temperature measurement, our media skills are still somewhat amateur, so just bear with me while I get my shot. So what we've got here is one of our ViroAlert units. This was just mounted onto a tripod. We've got a tablet computer just mounted underneath the device. So if I could just ask you to walk up to the device, Fiona. So I'm not sure whether that's quite clear for the viewers, but I've got a video after this to give you some more demonstration. There, if your eyes are good, you'll have picked up that the screen turned a nice green colour and told Fiona that she can pass. Typical measurement is somewhere in the order of less than 2 seconds. So it's a very rapid, quick process, very intuitive. We have one of these based in our reception, so all the staff are very familiar with using this coming in and out of the facilities, and you can get a good throughput of visitors through it. What I'll just do now is take you through a little bit of footage to just show you that in a little bit more detail. Just bear with me. So the footage that I'm just about through this footage is taken from the unit directly in our reception, and just to assure the viewers no staff were harmed in the filming of this excerpt, we've simulated a high temperature. So as you see, when the individual walks up to the screening system, the little yellow box indicates that it's detected a face. That's important. It allows 2 things. 1, automation of the system, and B, it prevents errors. So that should somebody walk with a hot coffee cup into the scene, it will measure the face and not the hot coffee cup. A number of competitor systems would fall foul of that and flag a red reading. So as you see, what we're seeing here is exactly what the user sees when they walk up to the system. So there's a prompt in text, please move closer to the measurement point until you're within the specified distance. This text that is showing up on the screen can be customized. So were this to be employed in an unmanned station, and there's specific contact details, contact reception, the nurse, etc., that can be changed to suit. And there you've just seen a simulated high temperature. Nobody was actually ill in this. He was just stood behind the door with a hot coffee cup pressed to his forehead. And it's very intuitive. So you've got a yellow color to indicate measurement, a green to say that you've got a normal temperature, and the red to indicate that you've got a high temperature condition. And we would recommend a process that after the initial screening, a subsequent final check is done with a medical thermometer. The basis behind that is the initial screening supplements all the existing protocols. It's non-contact, it's automated, nobody needs to violate any social distancing. If it should flag up that there is an issue, you can then carry out the secondary check with the tympanic in-ear thermometer to verify if there is an elevated temperature present. So it's one of the measures that we strongly believe that if it's implemented with adequate process and suitable equipment, can be a real strengthener to those mitigation methods to increase the resilience of an organisation. So just to sum up those points around the VirAlert 3, which is our temperature screening product, you have a dual thermal imager and visual camera. So that gives you the accurate measurement and automation through the face detection. So the face detection is similar to your smartphone, where your phone would focus on that part of the image. We use it to actually carry out the measurement in that area. It's not face recognition as some of the other competitors offer. The reason for that is face recognition is typically computational intensive, typically requires a link to cloud services, and with some of the providers that can produce concerns around privacy. The system that we offer can be set to either log live results, over temperature results, or every result, so that you have a full audit capability to look through and see and view the audit logs for any instances of alarms. But it's all contained in the laptop on site, and in terms of privacy, would be covered by the existing owners' privacy controls. It's been designed to be plug and play, installation typically in less than 30 minutes, and it's pre-configured and ready to go. As Fiona was saying, the key to all of this and reliable accuracy, because the amount of energy radiated from a human body is relatively low, getting reliable readings can be challenging. The use of a black body is imperative, and indeed it's part of the FDA guidance in terms of good practice. So our original innovation and patent has now become the gold standard, I think, globally. Moving that innovation on to the next step, we now have at the end of this arm that you see on the image on the right, the little black box on the far right is the combined thermal imager and visual camera. And then on the other end of this arm, which is about a foot long, 12 inches long, is the small black body source. Now, because we know the exact distance that is from the imager, and we know the distance of the person that we're measuring, we can do a real-time calibration, and the accuracy of our algorithm to give those repeatable results in real-world situations is very high. Without that, and with the black body that you can place in different positions, for different locations, as Fiona touched on, it makes the setup much more complicated, and the chances of that algorithm giving a reliable result every time are diminished. Rapid measurements, less than 2 seconds, and for any of our audience that are in the US, we are NDAA and FDA compliant. So the NDAA is the National Defence Authorization Act. This is made in the UK. We have no components within the system that would fall foul of that. And we also have market-leading availability, sub 1 week at the moment. That's throughout Europe, the Far East, and into the Americas. So just summing up those points again, face detection gives us the accuracy, eliminates false readings, it's privacy safe, does not use facial recognition, it's quick and simple. The idea behind this is it's quick and simple to set up, absolute minimal training, very intuitive to use. Just to give you an illustration of a typical setup, this is set up using a tripod. I'll run through some of the accessories that are available as well. So the tripod mount is ideal for a flexible measurement location that people are looking to move. Quick readings to enable high volume. And then we also offer point of measurement signage free of charge available to download to make it clear that it's a measurement process and to let users know what the expectation is. As you'll have noticed in the video, the users were removing their masks. There's two reasons for that. One is the face detection, but also in terms of good practice and guidelines, the recommendation is that masks are removed for temperature screening. If they're not, you can get a vent of gases up the side of the nose, which can flag an elevated temperature reading inadvertently, or the mask could be covering up a hot part of the face and prevent a high temperature reading